Hello, my name is Novi Puji Astutik. I'm a mathematics education student with student identification number 2302110011 at Universitas PGRI Madiun to fulfill the English course assessment with lectures Mrs. Restu Luciana, Master of Education, and I'm very happy to share my knowledge with you through this video. In this video, I will discuss the topics of set logic learning video. I hope you can enjoy and benefit from this video. Logic and set are two relation subjects in mathematics and science but have different focus and goals. Logic is a scientific discipline that studies reasonable thinking and method for clearing, separating correct reasoning from incorrect reasoning. Logic focus on the art of shape definition to clarify the content or extension of understanding or term. Logic also discuss proposition, truth table, tautologies, logical equivalent, normal form, and logical proof. Meanwhile, set is concept in mathematics that studies collection or group of objects or objects that can be clearly defined. Set focus on the meaning and symbol of set. Operation on set such as intersection, union, difference, edge, as well as analysis of component proposition and ordering rules. Set also discuss Venn diagram, set relation, set operation, and the basic properties of set operation. The main difference between logic and set is that logic focus more on reasonable thinking and method for separating correct reasoning from wrong, while set focus more on collection of definable objects and the operation that can be performed on this set. Both have with application in various fields of science and technology, but have different goals and focus in their approach and analysis of information. Truth table material in mathematical logic or truth table is a table used to determine the truth value of a logical expression consisting of several premises or statements. This truth table helps in determining whether a statement is true, denote B, T or 1, or false, denote S, F or 0. In logic, this truth table is very important for understanding and analyzing component statements such as conjunction, disjunction, implication, and implication, as well as for determining whether a statement is a tautology, all true, a contradiction, all false, or a combination of true and wrong. Conjunction material in mathematical logic is a component statement that adds the conjunction and to combination to single statement. The conjunction can be expressed with the notation P and he and read as P and he. The truth table for a conjunction shows that a conjunction will only be true if both statements P and he are true. If one or both statements are false, then the conjunction will also be false. Disjunction in mathematical logic is an operation that combines two or more statements with the conjunction "or" to reach a correct conclusion. Disjunction has two forms, namely inclusive disjunction and exclusive disjunction. Inclusive disjunction, the inclusive has to the symbol for and the truth table is as follows: P, Q, P, 4Q, BBB, BSB, SBB, SSS. In inclusive disjunction, a component statement is said to be true if at least one of the statement communicated is true. If both statements are false, then component statement is also false. Exclusive disjunction. The exclusive disjunction has the symbol then as truth table is as follows: P Q P, then Q B B P, P S S S B S S S S. In exclusive disjunction, a component statement is said to be true if only one of the statement communication is true, but not both. If the component statement has the same value, then the component statement is false. Implication material in logic and set is part of mathematical logic which discusses component statements that have a cause and effect relationship between two propositions. Implication was initiated by Charles Irving Lewis in 1932 with the aim of understanding that the meaning of a proposition is not only limited to truth and false but also has related consequences with it. Implication is a definition of component statement that adds the word if and then, which express cause and effect. The general form of implication notation is P with Q, where P is the first proposition that is a condition, and Q is the second proposition that is a consequence of the first proposition. The arrow form indication cause and effect relationship when can be read as if P then Q. Implication plays a key role in logical argument because if the truth of the first proposition is true, then the conclusive of the second proposition is also true. An example of implication in mathematical logic is if Agus learns using the internet, then Agus can study at home. In the context of logical and set, implication is used to describe the relationship between two sets. For example, if P is a set containing elements that satisfy a condition and Q is a set containing elements that are consequent of the element in P, then the implication P with Q can be used to illustrate that every element in P is also contained in Q. This also further analysis of the relationship between two sets and how they can be used in logical deduction. The implication matter in mathematical logic is a component statement that asks the condition if and only if and is written as P. Equivalent Q, the implication means that statements P and Q have the same truth value, either they are both true or they are equally false. In the implication truth table, the implication truth value will be true if the statement P and Q have the same truth value, either true or false. An example of the implication is 30 times 2 is 16 if or only if 16 is an odd number, which is a false truth value because 60 is an even number, not an odd one. Tautology in mathematical logic refers to a component statement that is always true for all possible truth values of its component. Tautology is the opposite of contradiction, which is always false. Tautologies can be proven using truth table or logical property. An example of tautology is the statement P or not P, which is true for all possible truth values of the variable P. Contradiction is a form of component statement that is always false for all possible truth values of its component. In mathematical logic, contradiction is the opposite of tautology, named a form of statement that only has the truth value or false for all possible truth values of its component. Contradiction is often associated with statements that cannot be simultaneously true when the existence of one statement will lead to the invalidation or authorizing rejection of another statement. Contradiction plays an important role in encouraging critical and analytic thinking, correcting error, encouraging understanding, and increasing the truth of an argument. Contingent set logic material is a part of mathematical logic and student component statements that are not always true and not always false. Contingent is a component statement that has a truth value that can vary depending on the truth value of its component. In logic, contingent is considered a statement that is neither tautological nor contradictory because it is not always true and not always false. Component statements that have different truth values can be seen in a truth table, which shows the truth value of the component statement for each combination of the truth value of each component. In the set logic contingent material, examples of contingent component statements are given such as P with Q and P which has the truth value BSSS in the truth table, showing that this statement is not always true and not always false. This component statement is an example of contingent set logic. The set logic contingent materials also discuss how to determine the truth value of contingent component statement. In this case, the truth table is asked to determine the truth value of a component statement for each combination of the truth value of this component. This set logic contingent material helps students understand how component statements that are not always true and not always false can be analyzed and calculated in mathematical logic. Conclusion from set logical material: truth table for logical operations such as conjunction, disjunction, implication, be-implication, tautology. Contradiction and contingency can be asked to determine the truth of a logical statement found in the truth table for each logical operation. Conjunction and PQP and Q, TTT, TFF, FTF, FFF. Disjunction are PQP, RQ, TTT, TFT, FTT, FFF. Implication PQP, RQ, TTT, TFF, FTT, FFT. Implication PQP, RQ, TTT, TFF, FTF, FFT. Tautology true for all PQP, QP, for Q, TTT, TTT, TF, FTFF, FTFT, TR, FFF, FTT. Contradiction for all PQP, QP, for Q, TTTF, FFF, TFF, TFF, FTF, TTF, FFF, FTT. Contingent but true and false. PQP, QP for Q, TTT, TTT, TFF, TFF, FTF, TTF, FFF, FTT. By using this truth table, you can determine the truth of a logical statement that asks this logical operation. Thank you.